everybody and welcome back to my channel. So in today's video we will be calculating time complexity for several functions. Now before starting with the video, to all people who watch my videos and they like my videos but they do not subscribe to my channel, so please don't do that and just subscribe to the channel. Also, if you want me to solve any particular question or algorithm of yours, you can leave it down in the comment section with hashtag #CodeMyQuestion. And I upload short notes on my Instagram handle, so you can go and follow me over there. I leave the link in the description box. Also, if you want all the codes that I write on my channel, so you can go to my GitHub account and you can find all the codes over there. I leave the link in the description box. So now let's start with the time complexity analysis. Now in the previous video we saw what time complexity is. Now what all has to be taken care of when you are analyzing time complexity. Now in case if there are any loops in the program, so we have to see the number of times the loop is running and the amount of work each iteration of the loop is performing. Or if we have any function call in my program, so how much time does that function takes. Now over here we have a loop running. So first of all we have to see the number of times the loop is running, and secondly we have to see that for every iteration how much work my loop is doing. Now over here we can see that my loop will run for the values of I which is less than equals to n, and the work done by the loop is the part that is over here within the loop. So over here we are just incrementing the value of I, so a constant work is done or work of order of 1 is done. So over here we know that the values for which my loop will run will range from 0 to n, and it will be like 0, 1, 2, 3, so on up till n, because over here I am incrementing the loop by 1. So here I can say that my loop is running for n plus 1 times. Okay. Now as my loop is running for n plus 1 times and the amount of work each iteration is doing is constant, because order of 1 can be written as constant. So the total work done is n into c plus c. So over here the part which is the most dominant is n, so we call it as order of n. So the time complexity for this particular function is of order of n. Now let's check this for this other function. Now see, but they both are the same. The only difference is that over here my I was being incremented by 1 for in every iteration, and here my I is being doubled, or it is being multiplied by 2 for every iteration. So over here also we'll do the same. First we'll see how many iterations are being performed, and then we are going to see what all work is done in every iteration. So in every iteration we do a constant work because only the I is being changed. And now see, let's see the number of times. Now first of all let's see what will be the values of I. Now over here instead of 0 let me put this as 1. Okay, so first of all the value of I will be 1. Then we enter this loop, then I becomes twice, so then this becomes 2. Then we again enter this loop, this becomes 4. And we are going to do this till a point that the value is less than or equals to n. So let me suppose that now first over here what we can see is first we have 1, then we have 2 to the power 1, then we have 2 to the power 2, and so on. Let me assume it to be 2 to the power k. Now this is the last value up till which my loop is going to run, and k plus 1 will be the number of times my loop is running. So what we can say over here is, now we have to calculate the value of k. So we can say that 2 to the power k is less than or equal to n. Now we'll just make it as equal to in order to get the maximum value of k for which it can run. So when it is 2 to the power k is equals to n, so we'll take log on both sides and k comes to be log n base 2. So k is log n base 2. So the number of times this loop is going to run is log n base 2 plus 1. We can simply ignore plus 1. We just want the major factors over here. So this is going to run log n times. And the work done is constant time. So we can say that the time complexity is constant into log n base 2. So overall we can say that this works in. Now let's see for the next algorithm. Okay, now let's see for this one. See, over here we were dividing, we were multiplying it by 2, and here we are dividing it by 3. So first the value of I will be n, then the value of I becomes n by 3, then it becomes n by 3 square, and so on up till n by 3 to the power k. Now we have to find the value of this k. So the last number for which it can run is 1. So here we will check for 1. That is n upon 3 power k is equals to 1. So over here the value of k comes out to be log n, but over here we have base 3. And the work done in each iteration is constant. So we simply say that the total work is the number of iterations into constant, and hence its complexity is order of log n base 3. Okay, so now let's see some more questions. Now in this question, see, first of all what we have to do is we have to calculate the number of iterations. We just calculated when my loop will go from n to 0, and every time we are decrementing or dividing it by 3. So the number of iterations will be log n base 3. Now inside my loop I am calling a function fn, and I say that I have already calculated its time complexity and it is of order of n. So this loop is doing a work of order of n every time this loop runs. So what we can say is this is the total number of iterations into n. So the time complexity will be of n log n base 3. So its time complexity is order of n log n with a base of 3. Now moving to the next question. Now over here we have to calculate the number of iterations made by this loop, and this is going from n to 0 with dividing my I by 3. So this outer loop is going to run for log n base 3. Now let's see for this. Now we have to calculate the work done by this while for every iteration. So the work done is this much. Now over here we are encountering another for loop, so we have to calculate the time complexity for this, because this will take constant time, and the total time it will take is the work for this, let it supposed to be Tn plus this, which is constant. So if I find the work done by this loop plus constant, this will be the work done by my iteration, by every iteration. So the net result will be the total number of iterations taken by this loop into the work done by it. So the work is this and the number of iterations is this. So this will be my answer. Now what we have to do is we just have to calculate this value of Tn. Now for this also, first we have to calculate the number of times this is going to run. So this is going to run from 0 to 19. So it will be for 20 iterations. And it is 20 iteration because over here we have plus plus. So every time my j is being incremented by 1. And the amount of it the work is doing is of order of 1. So into constant. So we can say it as 20 directly, order of 20. And order of 20 but is nothing but a constant. So this whole is so Tn comes to be constant. So we have log n into c plus c, which is these two are constant. And over here we have log n base 3. Now let these constants be C1 and C2. So over here we have C1 and C2. Now let's suppose the addition of this constant is C3. So what we can say is that the time complexity is C3 times log n base 3. So constant can be simply ignored, and hence the time complexity is of log n base 3. Now see, this internal loop didn't really matter because it is running for a constant number of times. Now let's see for this example. Now in this example we have to do the same. First we'll calculate the number of iterations made by this outer loop, and then we have to calculate the time complexity for every iteration of this outer loop. So we know that the number of iterations the outer loop is going to take is log n base 3. Now let's see the work done by this outer loop. Now this outer loop is doing the work of this loop plus a constant time in order to decrement my I. Now this loop is working for how much time? So we'll again do the same. We'll count the number of iterations into the amount of work it is doing. So this loop is working for the values from 0 to n minus 1. So total iterations will be n because we have a plus plus over here. So the values will be 0, 1, 2, 3 up till n minus 1. So n iterations are being performed for this loop, and the total number of work this loop is doing is constant. So n into c is the time complexity for this. Now the work done by this is the time complexity for this plus this. So this is taking a time of constant. So let it be 1 and 2. So this is the total amount of work done by this outer loop. And the total time complexity will be the number of times the outer loop is running into this into the work. So this into this will be my total time complexity. So this will come out to be order of n, and order of n into log n will be n log n. So the time complexity for this will be order of n log n base 3. Okay. So now in this question, now see, these two questions are more or less same. The only difference is that instead of decrementing my I by 3, we are going to increment the I by 1. And this loop has a little difference. See, over here, my outer and my inner loop were not connected, which means that my inner loop will always run from 0 to n, and the value of n is not changing at any point of time. But over here, the amount of work that my inner loop is going to do is dependent upon the value of I, and the value of I is being changed every time the outer loop runs. So let's see how we do this one. In such type of questions, what we do is, as the working of my inner loop depends upon the outer loop, we have to follow a different procedure. Now see, we'll calculate the total work done by this. How? By putting various values of I. Now firstly my I was 1. So the j will run only for value 0. Because then it will become 1 and it will come out of it. Now only one iteration. Now in the next time my I increments to be 2. And now the work done by the number of iterations will be, first j will go for 0. Then j will go for 1. Then it becomes 2, so it won't run. Then I becomes 3, so it will the values for j will be, the valid values for j will be, for which this order of work will be done is 0, 1 and 2. Then this becomes 4, and then we have 0, 1, 2, 3. So the last value for I for which it will run will be n, and in the last iteration the values will be 0, 1, 2, so on up till n minus 1. Now see, these are the total number of iterations that this whole program is going to have, because for every value of I we have taken all the values of j which will be valid, of which will make me enter my loop and do this constant amount of work. So over here we just have to calculate what is the total amount of work being done by these iterations and nothing else, because the all these iterations of I has been taken care of, because over here the value of I was 1, the value of j was 2, here it was 3, here it was 4, and so on, here it was n. So we have basically broken the whole this nested loop into these iterations. Now see, the number of iterations are, see over here we have 1, then plus 2 iterations, then over here we have 3 iterations, over here we have 4 iterations, and so on, and in the last one we have 0 to n minus 1, therefore n iterations. So the total number of iteration is the sum of these, and this is summation of n, which is equivalent to n into n plus 1 by 2, which is of order of n square. And these are the number of iterations into the amount of work done by this. So this is a constant, so into c, so it won't really matter. So the time complexity for this one is of order of n square. So this was all about how we can calculate the time complexity for several loops. This was all for today's video, and thank you.